Let's go to LeetCode 2762, continuous subarray. For this question, it gives us integer array nums, and let's count how many subarray, which is continuous subarray. So, uh, what is a continuous subarray? It is that mm, for every for each pair. Um, in the subarray, those kind of number, the absolute difference is smaller equal greater equal to 0 and smaller equal to 2, right? So that means for the subarray, the max and the mean, they need to have difference smaller equal to 2, right? So this one, it is two-pointer problem, right? So we iterate the right pointer, and we know um, uh, for the left, right? If it doesn't satisfy the condition, then we keep it moving the left pointer to shrink the size of the subarray, right? Until it fit, right? If, for example, the left point move here, and the maximal num in this subarray and the minimals in this subarray, the difference is smaller or equal to 2 already, right? Then any subarray end with right index in this kind of range will satisfy our condition, right? So our result should add right minus left plus 1, right? So we iterate our right pointer and use two pointer, use this kind of condition to shrink those kind of left pointer, right? And for this condition, we want to find um, any pair, right? Any pair. If we want to see any pair, um, we brute forcefully to have those compares. Apparently, the time complexity will not be good. But the thing is that if we get the maximal and the minimal, right, in this kind of range, then we don't need to iterate those kind of all of the pairs and of I and J in the range left and right, right? And to get the max or mean value in a sliding window, right? This right and left sliding window. The best way is that we have a monotonic deck, right? For this question, we want to have max and also our mean. We should need two decks, right? And of course, we can use tree set or heap, those kind of, but that will be have an n log n time complexity, right? But use monotonic deck, it will be a linear time complexity for the whole problem. Um, and the thing is that because we want to find the mean and the max in this kind of range, right? The right index included. So we need to know the steps is that first um, we put the right index into the mean queue, right? And for the mean queue, um, mean deck, right? We are looking for the minimal value. So um, every number which which has the number greater equal to uh, nums, right? We should be able to pull them out from this deck, right? And so so in this case, we are going to have we are going to pull from the right, right? So what left, the minimal value will be we pick on its on the top of the min Q, right? And for the mean deck, right, it will left the data like monotonic increasing um, uh, Q, right? And also for the max Q, as long as we are looking for the max values, as long as those kind of values on the left, on the max Q is smaller equals to current norms, right? We are able to pull them from the right, right? And how can we get the min and the max, right? We just use a pick. If it's not empty, just pick those kind of left, right? And I get the min and the max. And for the min and the max, here that is for current left and the right, the minimal value and the maximal value, as long as so that means that if the difference is greater than 2, right, we should shrink those kind of left pointer, right? Here we use another left pointer, and the thing is that we need to check whether this left pointer equal to the deck pick, right? If it need it if it equals, then we need to pull those kind of things from the left, and also the same with the min deck, right? And after those kind of max uh, minus min is smaller equal to 2, right? We have a local candidate, right? That is no, we are looking for the counts, right? So that the counts will be right, will result should plus equal to right minus left plus 1, because um, if we shrink here, the min and the max satisfy the conditions. That means all of the subarray will end with the right will satisfy the conditions, right? So we add it to our result. So let's write code for this. As we know, we need two queues, two deck, right? One called min deck plus new array deck, and max deck equals new array deck. So we need a left pointer. Let's have int n equals non-start length, and the left equals to 0, right? And the result is a long type, right? So we have long result to 0. So what we do is that for int right equals to 0, right smaller than n, right faster, right? So because the min and max, the right index is included. So we are first trying to see to pick right those kind of useless element, right? And also add right those kind of right index. So what we do is while max anyway min q min deck call min q, right? So that gets in simple. While min q is not empty, and nums min q tick last, tick last. If this is smaller equal to nums, right, then we're able to have mean great greater equal to, right? Because we this is the smallest one. So mean Q dot peak for last. And we have mean Q. Or anyway, we need to add last those kind of right index. And also we need to check the max Q, right? Why this kind of max Q is not empty. And nums max Q dot peak last. If this is small equal to nums, right, means those kind of values index in the max stack will never be useful anymore, right? So we have max Q for last. And anyway, we need to have max Q offer last, right? So now this part is the two pointer. Now we use a while loop for the to check the left pointer, and for the left pointer, we also need to check those kind of maintain the deck size, right? So what we do is that while this kind of max Q is not empty, and min Q is not empty, right? And so what is the max value? Max value will be nums max Q dot peak first, right? And if this one minus nums min Q dot peak first, if this one is greater than 2, right? Then what we need is that we need to shrink our left pointers, right? Uh, to shrink our left pointer, we also need to maintain this kind of deck, right? Deck, min deck or max deck. But the thing is that it's not necessary the left pointer is those kind of deck pick first because it's possible they are being pulled from last in the previous while loop, right? So we need to check um, if max Q does pick first. Um, let's say if this one equals left, right, we can put um, this left plus in the end. Then we have max Q dot pull first, right? And also we'll write if min Q dot pick first equals left, we're going to have min Q dot pull first, right? So after this while loop, then for this kind of from left to right, they satisfy that condition. The mean value and the max value and the minus mean value is small equal to 2, right? So any subarray from this left to the right will satisfy the condition. So our result should add equal to right minus left plus 1. And in the end, return result. And now also let's write a Python code. Um, so we need the data structure. That's right. From collections import back. So what do we need? We need a min q and max q equals to that and that. So what we need is left pointer and the result was zero, right? So for let's have also the length and was length of mouse. So for right in range and so while for example min q and nums min q the peak the last one, right? If this one is greater equal to nums right means any number in the min deck is useless. Well, in the future they will never be minimal value. So we just have min q dot pop, and after this while loop we have min q dot append, right. So the same thing with while max q and nums max q we pick the last value, right? If this is smaller equal to nums, right? Then we are able to safely pop or right or right. So we're good. And also we have max q append, right. So this is the deck, the right side that we add element. Uh, we pull out those kind of useless from our data structure, right? And then now this while loop is the left pointers. So while nums max q zero minus nums um, min q zero. If this is um, greater than 2, right? Actually, because we always append, right? So actually in the Java code, I think here we don't check if this is empty. It is fine, right? Because we always add element. So this condition will get rid of that. It should still work if we don't check this. It should work, still work. In the Python code. So if this one is greater than 2, we are going to have if left equals max q 0, right? And we're going to max q dot pop left. And we'll write if left equals min q 0, right? We have min q dot pop left. And we move the left pointer left to the plus equal to 1, right? And after we jumping out of this kind of values, we should add all of these kind of left to right, those kind of satisfy those kind of subarrays, right? Uh, the numbers. So will be right minus left plus 1. In the end, just a return result. It is ON time complexity, and also the worst case will be put every index into the DEX, right? So the space will also be owned.